Right, on page 5, study the example problems showing how to find the power of a power and the products of a power with the same exponent. Then solve problems 1 through 10. Anytime you are given an example problem on your assignment, you need to look over that example problem because there's usually some instructional information there. Definitions are also hidden in there sometimes. I know most of you probably jumped straight to the questions and then looked back at the example. If you read through the example, you can see the first one is same base, same exponent. What they mean is the power rule. Remember, the power rule is the one where you keep the base and you multiply the exponents. They're showing you two different ways. The first one would be expanded form. And then the second way would be using that power rule by keeping the base and multiplying the exponents. It doesn't matter which one you choose. If you expand, you take the base, 8 squared, and you write it as 3 factors, 8 squared times 8 squared times 8 squared, which expands again and becomes 8 times 8 times 8 times 8 times 8 times 8, which would be 8 to the 6th power because it was 6 factors of 8. The faster way is to use the power rule. You see the base, you see that the base has 2 exponents, so you keep the base, which is 8, and you multiply those exponents 2 times 3 to get 6. The second one is different base and same exponents. Remember, you have to have something in common in order to combine things. This time it's not a common base, it's a common exponent. Works the same way, sort of. You can expand just like before. You've got expanded form. That's the long way. You've got 2 to the 4th times 5 to the 4th, so you write those out as factors. 2 times 2 times 2 times 2, and 5 times 5 times 5 times 5. Then you would group those pairs up, a 2 and a 5, a 2 and a 5, a 2 and a 5, and a 2 and a 5. That gives you 4 sets of 2 times 5. 2 times 5 makes 10. And then when you have 4 sets of 10, you write that as 10 to the 4th. The shorter way would be to keep that exponent and combine the base. Now, there is not a plus sign, so do not add those bases. You are going to multiply. Pull that 4 off and sit it on the outside as the exponent, and then multiply 2 times 5 to get 10. Number 1 says the expression 8 squared to the 3rd in the example problem is a product of powers. What are the powers being multiplied? The second part says what are the powers being multiplied in the expression 2 to the 4th, 5 to the 4th. Now, you need to understand the meaning of the word power before you try to answer that. Power is not the base. Power is not the exponent. A power is the combination of the base and the exponent. So on the first question, or part A, it said, what are the powers being multiplied in 8 squared to the 3rd? We're looking for that base exponent combination. Those powers are 8 squared and 8 squared and 8 squared. We're using 8 squared 3 times. Part B wants to know what are the powers being multiplied in the second expression. This has 2 powers. You've got 2 to the 4th and 5 to the 4th. A power is the combination of the base and the exponent. Number 2, simplify 7 to the 5th to the 6th. Write your answer using an exponent. Simplify 5 to the 6th power. Write your answer using an exponent. When you see this one, this is a power rule example. You have 1 base. That base is 7. We're going to keep it. And then we have 2 exponents, 5 and 6. We are going to combine those by multiplying, giving us 7 to the 5 times 6 is 30. Number 3, they want us to simplify 6 to the third times 9 to the third. Write your answer using an exponent. On this one, the similar feature is the exponent. We have an exponent of 3 and an exponent of 3. So on this one, we're going to keep the exponent, pull it off to the outside, and we're going to combine those bases by multiplication. 6 times 9 to the third will simplify to 54 to the third. We've got 3 to the 5th to the 4th is equal to 3 to the 4th to the 5th. If we was to simplify these, the first thing you should notice is they both have the same base, which is 3. And when we combine those exponents, 5 times 4 on the left and 4 times 5 on the right. If you remember the commutative property of multiplication, it says it doesn't matter which order you multiply the numbers in, you're going to get the same answer. So 3 to the 5 times 4 is 3 to the 20, and 3 to the 4 times 5 is also 3 to the 20, making them exactly the same amount. Number 5, we're going to simplify 7 to the 5th times 4 to the 5th. We're looking for the similar feature. These have identical exponents. Both of them have a 5. So we're going to pull that 5 off and keep the 5. And we're going to combine those bases, 7 and 4, with multiplication. 7 times 4 gives us 28. And we keep that exponent of 5. Explain in words how to simplify 153 squared to the 7th. That would be 7 factors of 153 squared. We're going to keep the base, 153. Keep the base, 153. And we're going to combine the exponents with multiplication. Multiply the exponents, 2 and 7, to get 14, giving us an answer of 153 to the 14th. The statement 10 to the 5th times 4 to the 5th equals 14 to the 5th true. Explain your reasoning. It is not true. It is false, because you should multiply those bases to get 40, not add. The correct answer should have been 40 to the 5th. What is the value of x in the equation? 5x to the 5th is equal to 5 to the 35th, and explain. Since the bases are the same on both sides, we get to ignore it, which makes our exponents an equation of their own. You would have 5x times 5, because that is the power rule, is equal to 35. And then you would use those inverse operations to divide by 5, isolating x, giving us x equals 7. If you plugged that in, you would have had 5 to the 7th to the 5th, and you would have known how to solve this by keeping the base, multiplying the exponents to get 5 to the 35th power. Evaluating the expressions, tell which is greater, 4 to the 4th times 5 to the 4th, or 2 to the 5th times 10 to the 5th, and explain your reasoning. These have the same exponent but different bases, so we would keep that exponent and we would multiply the bases. 4 times 5 makes 20. On the second expression, 2 times 10 also makes 20, but it has an exponent of 5. So we've got 4 factors of 20 versus 5 factors of 20. The second one is a full 20 times greater than the first one. And that is your answer. It says that 2 to the 6 times 2 to the 6 is equal to 2 to the 12th, and also equals 4 to the 6th. Do you agree? Explain your reasoning. Now, we've got some yeses, we've got some nos. We can all agree that on the 2 to the 6th times 2 to the 6th, they kept the base and they added the exponents, right? That was mathematically correct. So we know that's correct. But on the second one, he said 2 to the 6th times 2 to the 6th is equal to 4 to the 6th. The question is that also mathematically sound? What we learned today was, if we have like bases, we can keep the base and combine the exponents. But we also learned that if we have like exponents, we can keep the exponents and multiply the bases. So we could have kept the exponent and multiplied 2 times 2, which gave him 4 to the 6th. So his answer was correct. It's two different ways to approach the problem. Both ways are correct. There is more than one correct answer. If you had multiplied this out the long way, you would have got the same answer regardless of your path.